All right, here we go. Let's talk about combining like terms today. So, first of all, it's pretty important that you understand that each term, so here's a term that's a constant term, here's a term that's a variable term, and here's another term that's a constant term. Make sure you identify what the sign is on each term. So, this term is a negative, this term is a positive, and this term is a positive. So always look to the left of each term, and that will tell you the sign on the term. So let's scan through here, and let's identify a constant term. So you might give it some type of symbol, right? Um, that's a variable term, so that is not like that term. This term is another regular number. It's a constant term, so it's like this one, right? So these two guys are called like terms. Now this term is a term, but it's a variable term. It's different than these, so you might give it something different. I'll give it a smiley face. So if we're going to combine like terms, we want to take the terms that are alike and think about pulling them out and sliding them together, right? Or you can rewrite your expression, right? So this is a negative 10. I'm going to bring this guy, this positive 2, pull him out and slide him in here. The commutative property says that we can do this, right? And then I'll take that positive 4x and I'll move him to the end. You don't have to rearrange, but it helps to understand this, and that allows us to successfully combine like terms, right? Okay, so we can go ahead and combine these guys, and the math behind that is going to be negative 10 plus 2, which is going to come out to be negative 8. And then this positive 4x variable term, there's no other terms to combine him with, so we still have to show him, though, right? We can't get rid of him, so we'll just put him in at the end, and that's as far as we can go, right? So our answer is going to come out to be an expression, a variable expression answer. There's actually another answer to this, right? So you could use the commutative property and flip-flop these two terms, right? So you could move that positive 4x to the front and put that negative 8 at the end, and those two answers are actually the exact same answers, right? We could, and you actually need to be able to see and understand each one of these answers, because if this is a multiple choice test or something like that, you might get this answer in your work, but this answer might be the answer choice. So you need to understand that those two are the same answers, right? Let's try another one. Let's try this one right here. Okay, so let's scan through here and let's identify our terms first. Okay, so that's a y variable term. There's another y variable term, so we might call these guys check marks. They're alike. And this guy here is a term, but it's not a y variable term. It's just a regular number. We call those constants. So maybe give it some other type of symbol. So let's combine our variable terms with variable terms. So in order to save a step here, instead of rewriting this, we could just imagine, right, sliding these down and scooting them together. Remember, the signs go with them, though, right? So if I pull that 45y out, that negative goes with it, right? So if we pull these down and slide them together, this calculation is going to come out to be 30y minus 45y. And that's going to give us a negative 15y's. And then this positive 15 or this plus 15 constants, there's no other terms to combine it with, but it's still there, right? So we'll just throw it in, still a positive 15 constants, and there we go. There's a good answer, right? And I bet you can see that we actually have another answer to that. And we could use the commutative property and rearrange these two terms, but make sure you take the signs with them, right? So that 15 is positive, so even if we move him to the front, he's still a positive 15 constants. And this 15y is a negative, so if we move him to the end, he's still a negative 15y's. So we get 15 minus 15y. That would be another answer, right? These two answers are equivalent. Right? Let's step it up a notch here. Let's look at something like this. Okay, so let's scan through this expression and pick out our like terms. So here's a regular number. Might give it some kind of symbol, right? We something different, give it a star. Let's keep scanning. That's a variable term, t variable term, not like that one. Here's a regular number. Okay, he is like that one, so these guys will be alike. and another t term here. So let's go get our t terms. These two guys are alike, so they're like terms. We might call them both check marks or something like that. Okay, so let's start combining. Let's take our two stars and we can pull them out, slide them together, make sure the signs go with them when we pull them out, right? So he's a positive 5 and this guy's a minus 10. If we scoot them together, that becomes the expression positive 5 minus 10, which will be negative 5. So if I take that negative 10t and that plus 15t, pull them out, put them together, that's going to become negative 10t plus 15t, which will end up giving you a positive 5 t's. And there we go. So we've done our combination of like terms there. So there is a good answer. And also, we could use the commutative property and flip those, which would become that answer. So those two answers are actually equivalent, right? They look a little bit different, but mathematically, they're still the same. Let's go on and let's combine a little bit of distributive property with this combining like terms. All right. So before we try to start sorting out terms, it's kind of like the order of operations. We need to complete any multiplication first, right? So this right here is actually one big term. Okay. So the negative 5 attached to this quantity by multiplication. This is a big term of itself right here. So what we need to do is we need to expand this term, right? So we need to run distributive property through and split this big term up into its individual terms. So let's go ahead and distribute the negative 5 through. Okay, so negative 5 times positive 6x, that's going to give us a negative 30x. And then our negative 5 times our negative 3, that's going to give us a positive 15. And then we'll just carry down the minus 20x. That's not a part of the distributive property, but that term is still there. So now we end up with something just like we did above, right? So now we've got this split up into its individual terms. Now we can start sorting. So we got a variable term, another variable term, and then this guy is just a constant, so he's something different. So let's pull these two out, scoot them together, and that'll become negative 30x's minus 20x's. So that'll end up being negative 50x's. And then we just got our plus 15 tacked onto that. And that's as far as we can go. We got a variable expression right there. Or we could use the commutative property there and flip those. And that will be another equivalent answer right there. All right, so there we go. We did some practice combining like terms.